Hello, welcome to the channel. The Radio Ninja here. The goal today is very simple. I just want to update you on everything that I've been doing for the past few months. That's it. How hard can that be? What the heck is this? Crap. Alright. I have totally been trying to make the same video for quite some time now. The reason why I haven't really been able to make it has a lot to do with the fact that how can I say this best? I don't know how to explain what in the world I've done. I don't know what approach I should take. I don't know what way should I do to make you understand, hey, this is what I've done. So what I've done right now is that I've made a brief list of things to go through, which I gotta say, in retrospect, I really should have done something like this a long time ago. But right now, it's better late than never, right? So right now, what I need to do, or what I have done, is written a list of things to go through. So let's just go through it. So first off, I need to create a system, something that if I follow will systematically simplify my experience and exploration to the task. The task is, well, making the robot. This is how I begin. So first, I've got to give you a brief update on what in the world did I do, because I will be doing myself a disservice if I didn't do that, I think. So that's the plan. Give you a brief update on what I did. And I guess I should answer where I started and what happened. I'll answer where am I now afterwards. So yeah, I think that's a brilliant idea. So I think, let's just rolling out the clips right now. Alrighty, I gotta answer the question of where am I now? Well, I'm gonna keep this simple and brief. I changed my initial idea. So instead of making a cable-driven robot to a humanoid robot. Right now, let's just update you on what I have right here. So this was going to be the robot that I would have been working on initially. First, I'll just simply explain what's happening with it, and I'll lead on to what made me to abandon the project. So let's start with that. What you see here is a visual system. It contains a camera and a distance sensor. And what these two things allows me to do with the robot is that first obviously gives eyes to the robot, and the other one is there to detect the distance between objects. So for example, let's say I use machine learning to detect, let's say, a spoon. I could use the distance sensor to be able to tell how far away an object is, and then I'm able to tell the robot, hey, can you please move closer to this object at the given, let's say, this far away from it. This is what I could do with the distance sensor. It also has another range of motion, which is it's able to tilt up and down, and also it has the ability to rotate around the whole robot. This ability is basically it's able to look around its environment without ever moving anything, just moving the head, or you could say the eyes of itself. This part here, it is basically a cable management system. All it really does is able to neatly stack away or wrap away rope in a neat manner. That's it, really. Of course, I did not design this thing. I literally discovered this idea online some time ago last year. The reason why I wanted to implement this idea was because just randomly wrapping rope around a drum, it made the robot to have unstable motion. And this mechanism, even though it's complicated, it will allow a smooth operation, which is what I want, of course. I want it to be stable and very steady. And this mechanism, I think it's gonna do the job. Down below here, there is a computer and another motor, which controls the slew ring. Now, this slew ring allows the whole bottom part to rotate 360, and yet I'm able to use the slip ring to still transfer power to the motor and the computer, and of course be able to get the sensor data from up above. And yeah, that's really all it is for the bottom part of it. Now, this part that you are now setting your eyes on is basically the part that caused everything to change. When designing this part, it basically made me to say, if I can make a robotic hand out of, let's say, Makaban muscles, why can't I make a whole body out of Makaban muscle using these designs that I've just created here? That's all it was. And that idea made me to think, to say, hey, I create this design. If I can make a hand, I can make the whole body of a robot. So this took me a long time to try to design. To be honest with you, there is only two things you really gotta understand about this whole structure. And despite how complicated it looks, it is really simple, to be honest. So let's begin trying to explain what the heck is happening. So first, alright, President Brian here. Now you're probably looking at this structure that I've created here and now puzzled and questioning, why would I even create it in the first place? Well, the short answer to this is this. You see, I want to control lots of Makaban muscles, and I mean something like 100 and so on. Now, the existing way in how I can control the Makaban muscle is simply not feasible. You see, in order for me to control a Makaban muscle, I need a solenoid valve, which is basically something that allows fluid to flow in and out of a Makaban muscle. And the thing is, every single Makaban muscle requires individual pneumatic to be able to control the state of the Makaban muscle, to whether it's relaxed or contracting. So this design is here to address controlling lots of Makaban muscles in such a small area. So I think, you see, I haven't even tested this design yet, so it's gonna be an interesting find to see whether this structure even works in the first place. So this is my take to this. The disc basically allows to interchange different input and outputs. Let's say I'm using a motor to pump fluid into this McKeban muscle. The input being the high pressure, which means if I were to expose the McKeban muscle to the input, the McKeban muscle will start to contract. If I expose the output to the McKeban muscle, is gonna relax. That's all you really gotta understand here. This is literally what this whole design is all about. Exposing different pipes, different McKeban muscle, causing it to contract or relax. So, given when the disc spins, it allows different holes to line up to these upper pipes. When that happens, different drums are now exposed to different pressures of input or output. Let's say the upper drum is the input and the lower drum is the output. What then happens is the McKeban muscle that is now exposed to the upper being the input, it causes every single pipe that is now getting out of the upper drum that feeds to the McKeban muscle, it contracts. But there is a trick to it. It doesn't just do that. So I've designed these drums to have holes in such a strategic ways, whereby given that the motor that spins the drum spins at different angles, it will allow different holes to line up with different pipes, causing different McKeban muscles to expand or contract. And this is all it is to it, really. Okay, if you've made it this far without skipping, I salute you. I mean, it was really boring, let's be honest here. Hopefully, my next video in just 2 weeks, it will be a little bit more interesting. For now, it's time to say goodbye. So yeah, if you have anything to say or any question about any of these things that I'm making, please comment below. And yeah, well, and let's do this.